Nuclear Chemistry, Part 1, an Introduction. In this video, we're going to compare and contrast chemical change and nuclear change. In chemical reactions, we study how molecules and atoms break old bonds and form new bonds. For example, when hydrogen molecules and oxygen molecules break their bonds and form new bonds together as water molecules. The chemical bonds are what change in a chemical reaction. On the other hand, we shall see that in nuclear reactions, the nucleus of an atom can combine with another, or the nucleus can split apart, or the nucleus can emit radiation in the form of particles or rays. For example, a large uranium nucleus can split apart into a krypton nucleus and a barium nucleus. The nucleus is what changes in nuclear reactions. In the study of chemistry, we tend not to pay too much attention to anything except for the outermost electrons, the valence electrons of the atoms. Valence electrons are transferred and shared in chemical reactions. In nuclear reactions, we will see some action from the electrons, but only as they interact with the real star of nuclear chemistry, the nucleus. The nucleus's protons and neutrons will be a part of the reactions in nuclear chemistry. While chemical reactions do involve the absorption or release of energy, often in the form of heat, sometimes even a lot of energy, like when dynamite is used to bust up a rock quarry, that is nothing compared to the extremely large energy changes we will see in the study of nuclear reactions. It's hard to compare the devastation of a bunker buster bomb, which can take down a mountain, with the complete destruction capable through modern thermonuclear warheads, which can take down a whole mountain range. Nuclear reactions involve a much larger energy change than do chemical reactions. In a chemical reaction, the atoms themselves do not change their identity. They just rearrange to break and form bonds through their valence electrons. If a carbon atom is present before the reaction, it is still present after a chemical reaction. It just may be in a new molecule. For nuclear changes, the atoms turn into different atoms, making new elements. The dream of the alchemists, turning lead into gold, is entirely possible, but not with a chemical reaction. You need a nuclear reaction to make different elements. And lastly, we've seen how chemical reactions can be sped up and slowed down by changing things like temperature, pressure, and concentration, or by the addition of a catalyst. In a nuclear reaction, we don't really change how fast it is by changing the conditions of the reactants. The nuclear reaction takes place because the nucleus itself is unstable, so we don't really have any say in how fast or how slowly the process is. So here's a sample question for us. Of these four statements, which one applies to nuclear reactions, but not to chemical reactions? Option A, the identity of the atoms involved does not change. Option B, the valence electrons are shared and/or transferred. Option C, the number of protons and/or neutrons in an atom change. Or option D, energy can be released. Which one describes nuclear change, but not chemical change? The answer is option C. In a nuclear reaction, it is the nucleus, where the protons and the neutrons are, that changes. Chemical reactions deal with valence electrons being shared and transferred, so they don't impact the nucleus at all. Thanks for watching this video. Hopefully, you've learned a little bit about the differences between chemical change and nuclear change.